Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, Episode 15, Lua. Take it away, Jason.
Hey, everybody. So, if you're wondering why the cadence of the show slowed down a little bit, it's been a little bit more than 2 weeks.
People don't wonder anymore.
Yeah. It's because Patrick and I were on vacation. Patrick was in sunny, beautiful Florida.
No, it was just really hot.
Oh, really? Oh, man. Already? It's only May.
Yeah, but it was like really humid and 90 something. And
oh, man.
You don't realize how quickly, and we're going to sound really obnoxious, Jason, just forewarning people, because we're like, oh, sunny California. And, but you really do get used to it really fast. And Florida has amazing weather. But I went back and I sweated the whole time.
Yeah, I remember when I went back to Florida to visit my fam, I remember my glasses fogging up, like when I got off the airplane, and like I couldn't see anything, and it was like just so damp.
Yes,
like
it's so
hard
much
to
more
breathe.
humid and hot. Ugh.
Yeah, terrible.
Now we sound like whiny, but that's okay.
I was in not humid Alaska for a couple of weeks, and that was pretty wild. We hiked all the way up to a glacier. A couple of guys got buried in the snow, and we had snow shovels. We had to dig them out. We were walking on these like snowshoes, which are, for people who don't know, they look kind of like a beaver's tail. They're like really like flat and wide. And the idea is like you won't break through, because the way it works is the snow keeps piling on top, but the sun, especially during the day, sort of like heats up the snow, and it creates kind of like a shell, because it's like this water is heating and then cooling a lot. And so you have this shell of that's harder than the snow itself. And underneath the shell, you have this soft snow. And so the snowshoes allow you to sort of walk on this shell without having to like trudge through the snow, right? But if you do fall in, your snowshoes like break through, then like you sink in, like, and people are sinking in like 3-4 feet into the snow. And then the snow sort of like, it's not like quicksand, like you don't sink in it or anything, but like you fall through the snow, and then the snow like comes around you kind of and like entraps you. And especially since you have the snowshoes that are like attached to your feet, like you can't lift them up because there's just too much snow has like collapsed on you. So
and
so
this
somebody
is fun?
has to yes, we did all this to go to a glacier and take a lot of pictures. But the adventure was the fun of it.
I think they have helicopters for that.
Yeah, we could have taken the helicopter. Instead, we hiked it. So our parents, my in-laws came, and they actually took the helicopter. So we met them.
Did they meet you out there? Oh, okay.
Yeah, we met them there, and then they took the helicopter back. And it was about, I think it was like 8 to 10 miles. So it was quite a hike. And we were pretty exhausted. And at one point, the tour group leader was like, you've only done 50% because we got to go back. So
those are the
really
words
tired.
You don't want to hear.
Yeah, but some cool things about it. One, we saw some black bears. That was pretty cool. We learned the difference between black bear, grizzly bear, and polar bear. So black bears are the least threatening. They pretty much run away as soon as they see you. Grizzly bears and polar bears are like much more dangerous, and brown bears are also pretty dangerous. What else? Oh, the tour guides made this awesome stuff. They took like cocoa powder, like you'd use to make hot chocolate, and Tang, and put it together, and they made hot chocolate Tang. And it tasted like, those orange chocolates? Like it's like a huge orange shaped chocolate, and you slam it on the ground and it breaks into pieces, It tasted like that. It was really good.
Yeah, sure.
So yeah, I was kind of hiking in the wilderness, but we're back with Lua.
You survived.
So. Yes, we did. It was pretty awesome. I have some pictures posted. I'll share them with the Meme Hub page, so that anyone who's following the page will get to see the pictures of the hike.
Or the Programming Throwdown page, maybe too.
That's right, the Programming Throwdown page. Yeah. What did I say?
You said Meme Hub. You have too many pages.
Oh no, I have too many for real. I think I'm gonna add a third page now, so it's gonna be just ridiculous.
Uh-oh. Spoiler alert. All right, so the news of the week is Facebook So Jason, I think, uses Facebook some. I have an account, I think, somewhere. All I know is Facebook keeps emailing me and saying, you have like 30 something friend requests. And I'm just like, I don't care. You should detect that I haven't logged in years. So I got one when it first came out.
As
and I
like
just don't.
the OAuth. Like some things now will let you log in using your
Right.
Facebook ID.
Like single
And
sign-on, yeah.
yeah, I'll do that, but that's about all I use it for.
Yeah, so actually, I'm interested how many of Facebook's 900 million users are doing that. Like only interaction, or is it 900 million is like registered, and then I forget how many they claim are active, but how many of their active users, are logging onto Facebook.com, being served ads, and, interfacing with the content. How many are accessing it like on a mobile device where you don't get ads, and then how many are just using it like you for, just logging into other websites, authenticating with stuff, or just playing games?
Yeah, well, I read an article that over a third of people just log on Facebook to play Zynga games. So
Wow.
yeah, so
Farmville.
but
Nobody admits to playing that game, but I know there has to be a ton of people playing that game.
oh yeah, totally. There's got to be. But
So,
I mean, even if it's true and people aren't, the whole wall, post on the wall, share with your friends, if that's kind of like gone with the dodo, it's still pretty useful technology, just being able to identify people and their relationships, and a lot of applications need something like that to be, even better.
but is it worth hundreds of billions of dollars? And that's the question that was asked at the end of last week.
That's right.
So Facebook IPO'd their initial public offering, and Jason and I are not business majors. We are not financial students.
Oh yeah,
Of
yeah.
any.
Let's put a disclaimer here. We don't take this as stock market advice or anything like that.
Yeah, this should not be construed as trading advice in any shape or form. But yeah, so it was really weird. We were watching it, being in the tech industry, people at work were interested in this because it's it hit mainstream, right? So even the morning news was covering Facebook's IPO, and it being local to this area, the Silicon Valley, that, it was big news. And so people were watching it, and it was just one of the weirdest things, I've seen, that people were just talking about it, and then stuff just seemed to go terribly wrong. So when it first opened, it turns out afterwards, I was trying to read because, when I think it was LinkedIn or Groupon had IPO'd, I tried to watch it because I was curious what would happen. And it didn't open with the market, but this was expected. And actually news reports said this was going to happen. But Facebook was supposed to start trading when the NASDAQ opened. They're going to trade on the NASDAQ, or they are trading on the NASDAQ. But it turned out the NASDAQ had technical difficulties that delayed the start of trading for like almost 3 hours or 2 hours, 2.5 hours, something like that. And so I read a little bit about it, trying to understand. And the best explanation I could kind of come across was that the IPO price, that very first price that it's going to start at, is calculated by how many people kind of say, I'm going to buy shares at whatever price it opens at, right? So before the market opens, they put in an order with their broker. I don't care, buy it right away, And those are matched, which is the whole purpose of, the exchanges. So the New York Stock Exchange, NASDAQ, the Chicago Board of Exchange, these different markets, their whole point is matching somebody who wants to buy with somebody who wants to sell.
So I don't want to derail you. Like you can table this, but I don't know the answer to this. What's the difference between the New York Stock Exchange and NASDAQ? Like, are they just two different people who do the same thing?
The technologies behind them are kind of different, but
Oh, okay.
and essentially they're doing the same thing, which is at the base level they're matching buyers and sellers for a given stock. So
Gotcha.
that if you want to trade, I'm trying to think of something that's on the New York Stock Exchange. I'm not good at this. Like AT&T, let's say, is on New York Stock Exchange. Then you need to go there to trade it. Versus if you want to trade Facebook, it's on NASDAQ, so you need to go there to trade it. And your broker hides this. So your broker's job is to talk to somebody whose job is to talk to somebody whose job is to talk to somebody whose job is to talk to the exchange.
Okay.
And in the old days, that used to mean like some person on the floor waving a piece of paper and screaming, I have an order for 5 shares. And he knows it's from some guy named Jason Gauchi, but nobody else knows. He's like, I got 5 shares. And somebody else goes, okay, I'll sell you 5 shares, But now that's all done by computers, and it's done at matching. And at each level it goes through. So like your broker, the clearinghouse for your broker, like these successive levels away from you, they can match people who also are using. So like if you use Fidelity, let's say, Fidelity can match you against another Fidelity customer instead of having to go all the way out to the exchange, because then Fidelity makes more money that way because they don't have to pay the exchange for this service.
I see. It's almost like sort of like you could relate it to like electricity or water or something like that.
Yes,
Like
you
if
go to the
have
nearest
go
person
to,
who can give you the supply.
Yeah, right.
Right. So, okay, so all this, so like the NASDAQ, when it was opening, had all of these orders because, of course, the people selling were in very small area, right? So Morgan Stanley and I think a couple other investment banks. So they were the only people who were kind of giving sell orders to the NASDAQ. And then people across all other brokerages had buy orders. And so what NASDAQ needed to do, again, this is Patrick's understanding of reading a couple articles and trying to figure out what happened, is that they have to kind of figure out what that first price, what it's going to open at is. And so they have to go and match. So Jason wants to buy 1,000. Morgan Stanley wants to sell 10,000. So, okay, I need to adjust the price to and fro, do this and that. There's limit. They need to go through and basically have a queue of all of the buys and sells, match them against each other, and determine what the final price at the end of all of that is. But what happened?
So if I understand right, so the price of a stock, so I guess so. Some people say I'm willing to buy, but only for $30, and someone else says I'm willing to buy for up to $40.
Right.
And then the person's saying like I'm willing to sell. So obviously like the thing's gonna try and match up the person who's willing to spend more. So it decides, the price of the stock should be $40 because this guy's willing to spend 40. But then if the guy who's willing to spend 40 isn't buying all the shares that are up for sale, the guy who's spending 30 is buying half of them. Now the price is 35, something like that.
Yeah. So it's whatever the last price of a trade took place. So yes. So normally when a stock's not moving, it's because Jason says I'll sell for 30 and I only want to buy for 25. And so there's a gap of $5 between us. So an order doesn't take place. And then it's not until somebody else comes along, like maybe Jason says, okay, I'll sell you for 25. Then that's the last trade. So that's the price of stock, 25. So basically there was all of these orders stacked up. And sometimes you can say, I don't care, just buy me some. I don't care what the price is. Right. And then what it'll do is it'll say Jason's willing to sell at 30. So I'll buy all of his at 30. The next person's at 35. I'll buy all theirs at 35. And then the person buying will get some at 30, some at 35, some at 40, whatever, as it goes up. And so all of this has to take place to figure out what the price is going to be at open. And what my understanding is the way the NASDAQ software was written is that they had kind of a unforeseen consequence where before the market opened, somebody modified their order, said, I don't want to buy 1,000, I want to buy 500. And they could do this because the order hadn't been executed yet. The trade hadn't taken place. But when that happened, when that queue had been filled up and, millions and millions and millions of these, orders were in there, that when they got to one of these modifications, they kind of had to go back to the start and go again because they had assumed, at, 0.5 million that they had, an order for this, but now the order was actually something different. And so they would need to kind of unravel back to that point and kind of play it forward again. And so they had this loop. But then because they had to go through all of these modification orders and it was taking a long time because there were so many orders out there that when they came, that caused a delay. But then during the delay, other people freaked out and go, what's going on? Cancel my order, modify my order too. And so every time they would hit one of these, they kind of had to start over again. And so they just kind of ended up in this vicious cycle of delaying for hours trying to get through this mess. And so eventually I guess they stopped that and changed it so that it would ignore the modification orders or something. But it caused a pretty big, mess that this is a big brand name IPO, Facebook, first day, and then for 2 hours, nothing happened.
Yeah. And I mean, what the article is sort of alluding to is that, Facebook, before they went public, they had, I think it's Goldman Sachs that was trading these private shares. So you could buy a piece of, and so basically those people didn't have all of these things happen to them or whatever. And so they were able to sort of strategize and buy at the right time and get in on it sort of early and things like that. And those people were probably all leaving, right when it IPO'd.
Yeah,
they were all selling.
Because, they bought in at 20, right?
Yeah, exactly.
So that's the other thing is there's all these people trading beforehand. There was these issues that, if you were just you or I, you'd have no idea what was going on. I only figured this out much later when I was reading about, reports about what happened. And then the other thing that happened is the stock started to drop once that problem was fixed. And then it started to go back up. And you're like, whoa, it's going back up. This is great. It's going to happen. The IPO pop. And then it turns out that was the Morgan Stanley, the people doing the IPO, that was them like trying to pour all of their money into buying the shares to try to get the price to go back up and get people excited about it. But that only lasted so long. And then it dipped again. And then, Monday it dipped even more. And so now it's like on a slide downward, which is kind of bad. But all that to say that it was very complicated. And it turns out if you didn't know what was going on, you probably were just going to get hurt.
Yeah, I mean, I think that, it's one of these things like it's always been like personally, I always like to invest. Like I've only invested a little bit, but I remember when I was in college, I had a little bit of money and I invested it in Apple. I think I bought like one share or something like that. Because you're like a broke college student. But it's like fun to invest in things that you believe in. And sometimes, if you believe in something, it's more than just like trading based on the statistics. Like you're trading based on like kind of like a educated insight in things like that. It's like at the time I bought like one of the first, I think I bought like the second gen iPod, and I was like, this thing is great. This music player is awesome. So I'll buy like one share or whatever. And it'd be fun to sort of do this with Facebook and say, look, Facebook, they're providing awesome technology, and it's a way to sort of bring people together, et cetera, et cetera. But if you try to buy, at least right now, you're just going to end up getting caught up in so many people who are just playing this as a game and not, as an investment.
Yeah, absolutely. And I think it's one of those things, and you have to be honest with yourself. If you're buying it for a long term, don't look at it. If you find yourself looking at it and thinking about it, you're not in it for the long term.
Yeah, good point. Good point. And
so,
I really don't know if so many people have said, oh, I have this great strategy, and we're constantly like on the neuroevolution users group every week. Somebody's like, oh, I want to use this neuroevolution program to do stock market trading. And if I give you one piece of advice from someone who's done a lot of AI in his life, just don't bother. Invest in companies that like you either believe in or you see they have a good future or things like that, and just keep your money in them for a really long time, and just treat it as sort of, and if it goes up and down, like what Patrick's saying, just ignore it. And all of this like trying to like do all this gamey stuff and things. There's just so much infrastructure in place to do all of this. Like we went to one talk where this guy was doing, what was it, like nanosecond trading or something like that, and they had written their own operating system to do this trading. It's just insane. So
yeah,
this is just crazy. Another case of that.
And if you think, I don't know, like if you hear people saying they've got a system, they're probably not very successful, and that's why they're trying to talk about it and sell something.
Yeah, it's
if
true.
They were really successful at like this system, they would just use the system until they didn't need money anymore.
Yeah, exactly.
Now, that's not completely true. There's caveats to that. But for the most part, the people who are loudest about the stocks are typically the worst traders. People who are really good at it tend to be quiet and not say much.
Yeah, that's right. And it's fun to fantasize about being like some kind of crazy like white hat hacker AI like super genius who like makes some program that makes a bunch of money. But in reality, there's just like massive hedge fund like based institutions that have like hundreds and hundreds of like postdocs and ex-professors, things like that in AI who like do this kind of stuff. And that's just like, for them, it's just like owning a construction company or something. They go in, they put on their hard hat, and they just like hack the stock market all day, So just like one person, no matter what kind of like talent or anything, is just not going to stand up to something like that.
Yeah, there are always exceptions to the rules, but it's like anything. You have to look at the odds, right? That you always hear the kid who wants to be the NBA basketball player, and I feel bad for them, but I try to point out that's statistically unlikely.
Yeah, that's
like,
right.
But you don't know. I'm really good. I'm like, you're right. I don't know how good you are, but I mean, unless you know you're the best in your state, the best person you've ever played basketball against, you're not making it to the NBA.
Yeah, and again, that's a perfect example. The people who make it to the NBA, by and large, are people who played in like amateur athletic union, played in high school, played in college, and by the time they get ready to enter the NBA, they have like this whole history, and they have like I don't want to say like an entourage, that's not the right word, but they have like connections. They know the ins and outs. They know how the play is supposed to be run. Like they can go to the coach and they speak the same language. Like there's all this infrastructure, social and physical infrastructure in place already. Like you couldn't take somebody who has just incredible natural talent and expect them to make the NBA, like, without going through these phases.
Yeah. So, well, our second news story, not to dwell on finance stuff forever. This is a programming podcast.
Yeah, totally.
Twitter has changed. They want to do better at recommending who to follow, what to do, what things of interest. And so they're going to start kind of, I guess it's going to be opt-out, but they want to start doing more tracking of their users to figure out what they're doing, to figure out what they're interested in, so they can provide better recommendations. And, of course, as always, people are upset. Twitter wants to track you. They're invading your privacy. And although, in one hand, I guess that's technically true, it comes down to the thing I want to bring up with this article is this problem, this walk that these companies have to do to straddle making something that's useful to you and respecting your privacy. Some things you can provide in a perfectly anonymous manner, but it is actually what they're trying to do. I feel it will be better if they track me, but them tracking me means they have information about me that I don't necessarily want them to have. And so how do I make that decision? How do they make that decision? How does somebody who doesn't understand any of these things make that decision? It's very complicated, and it's something more and more that I think Facebook, Google, Twitter, all these people are having to address. How do they provide tailored, personalized, useful results to their users without invading their privacy too much?
Yeah, definitely. I mean, that's a huge, huge concern, right, for these companies because, like, let's say Twitter makes this and there's a hole in it and somehow advertisers get access to, like, your interests at a very deep level, and let's say they get access to your address even and things like that. I mean, this sounds really far-fetched, but I actually went to and this is real. I went to what is the word? A conference where somebody was giving a talk, and they actually, using Twitter posts or tweets, I guess, they were able to determine someone's location of where they lived with like remarkable accuracy. And they used so Carnegie Mellon has a Twitter like data set. So I don't really know much about how it works. It's somehow anonymized, but basically it's like a slice of all of Twitter's data. And so researchers can use this information that's been scrubbed somehow to do various experiments and things like that. And the kind of things that people can deduce is just shocking. I mean,
I saw one that it was just by the dialect, like the words you use are regional. So you can identify where somebody is in the country by just the words they choose to use, even in their 140 character tweets.
Yeah, that's a big part of it. And they also do it's based on your connectivity, like people you're connected to. Because you think about this, right? Like if they could figure out for half of the people, then they could just use the connectivity, like who's friends with who's following who, to figure out the other half, So if one person says, "Oh, I went and saw the Giants. I walked to the Giants game today," then it could use that phrase to figure out, well, they must be really close if they walked. And so everyone they're following, is statistically likely to also be in San Francisco, et cetera, et cetera. And they can build all these inferences and layer them on top of each other. So yeah, I mean, there's the short of it is there's an incredible amount of interesting things that they can deduce from your information, and they can use that to sort of provide like really like targeted based, whether it's advertising or whether it's giving you information, whether it's assisting you with your searches, or there's tons of things that Twitter can do with this data. But yeah, at some point it crosses the line of being creepy. And that line is different for each person. That's what makes it so difficult.
Or not even the creepy, but just like you said, the risk of somebody leaking out information you didn't want leaked out.
Yeah, both of those are just really dangerous. Like that was one of the big things with, there was some social game, I can't remember what it was called, but it was basically like you managed an aquarium, and like there's different fish, and your friends had fish or something, and they were doing pretty good. It was like a startup, and they had like a few million users, and people were buying fish and things like that. Then they did something which was kind of sketchy. Like I can't remember what it was. Oh, it's like somehow they'd figure out where you lived based on like your Facebook posts and things like that. Then they try and like put you in an aquarium with other people who live near you, and the whole thing died. Like people got freaked out, and a bunch of people canceled their account, and that startup went under like almost immediately.
Wow.
Yeah, so it's like a huge concern is walking this line between, oh, this is really cool and, oh, this is totally creepy.
Well, on to something completely different. I read this article I thought was really cool. We've talked in the past about microcontrollers and embedded programming. And here's a guy, we have a link in the show notes, but who is programming and controlling his Arduino, which is one of these small embedded microcontrollers, with JavaScript. And I thought that was really cool how somebody had a passion. They really want to write stuff in JavaScript. And so they actually figured out how to use JavaScript to do something you wouldn't expect.
Yeah, yeah, totally. That's pretty awesome. That's a benefit between, I mean, remember like it wasn't too long ago where compilers were totally closed source, locked down, and it's like you would take your C or C++ code and you'd build it using GCC, and then you'd build it with the Intel compiler and you'd build it with like this other compiler and all these, it'd be so much faster and things like that. And it's just nice to see that like the whole industry has really matured and all of these tools are just totally open and accessible. And if you want to do something crazy like this, like recompile the JavaScript virtual machine for Arduino, that you have the freedom to do it.
Yeah, so I guess the way this actually worked is there's Node.js, which is a C++ JavaScript interpreter that actually I guess powers Chrome. Is the same one, so V8, is that what it's called,
Right.
I believe?
That's right.
Yeah, and so in there, because of the C++, they could basically craft an interface between the JavaScript portion and the C++ portion, which had access to the serial ports. So you could control commands out the serial ports, and then with a little bit of fiddling and magic wizardry, we'll call it, the serial commands that got sent across, you could send across special ones that were interpreted on the Arduino side to blink a light or read a sensor or whatever.
Ah, nice.
So
That's awesome.
it's pretty cool. And it's kind of crazy to see what lengths people will go to use something that isn't necessarily the first closest tool for the job that you would expect. So people would normally say like, oh, C or C++. But here's a guy who took JavaScript, maybe one of the least likely ones you would say, and got that to work as well because that's what he liked.
Yeah, isn't that crazy how popular JavaScript is becoming? Like, it just blows my mind. There's there's Node.js, which is pretty awesome. Then there's I'm totally drawing a blank. The Android, what is it called? I think it's called like Mojave or something. But basically the thing is you write JavaScript code and then it turns your JavaScript code into either like or it has, I guess, a virtual machine written in Java to run your code on the Android.
Mm-hmm.
And it also has one written in Objective-C. Let me see if I can find this.
Okay.
But yeah, basically, so people are writing native like phone code in JavaScript, and then it's like then they're just compiling it or they're running it on all the phones. So they don't have to like
nice.
write their code in Java, write another copy for the iPhone, write another copy for the Windows Phone, et cetera, et cetera.
Oh, cool.
Yeah, yeah, JavaScript is becoming extremely popular. I mean, it already was popular, but it's just growing at an alarming rate.
Well, on a similar topic to controlling real world things through your computer, I guess this is another dream of science fiction, but I read an article about people controlling robots with their brain. And so this one was actually, I think she had a lady who had a brain implant was able to get a robotic arm to bring her a cup of coffee and actually tip it into her mouth so she could drink some. Why use a very
nice.
steaming hot beverage? I guess just to show how confident you were in your system. But that seems dangerous to me. But it is an amazing feat, and there's a lot of problems. And they said that they had to do it multiple times, and like I think they said it worked like 4 out of the 5 times, or 3 out of the 5 times, or something. So
There time she was burned horribly.
Oh no! I think she just dropped it or tipped it over or whatever. But yeah, so it's kind of cool. This brain computer interface is for paralyzed people, and that's just amazing that what it might be able to do to help those people, and then one day maybe even the rest of us to be able to do that is, like I said, a dream of science fiction and young kids everywhere.
Yeah, I mean, everyone should watch this video. It's amazing.
So
How does that work? Is it based off like I mean, it's not literally like it hasn't punctured her skin,
Yeah,
right?
no. This one has. So what they do is
Okay.
I think it's a sensor, maybe they're like the size of a grain of rice, something really small, and they bury it in a certain portion of the brain. So
Oh
they kind of
wow.
like drill a hole in your brain and put this long needle with something on the end of it into the certain point, and then there's a bunch of little probes on the end, is what I understand, and they measure the electrical spikes in the area of your brain. So neurons, when they fire and talk to each other in your brain, when your brain has activity, those emit EMI signals, electromagnetic signals. And so or I guess just EM signals, adding extra letters. And they're able to pick those up, measure those, and see that your brain has activity. But at first, it just kind of seems random because you have no idea what neurons you're next to or what exactly they're for or what they're doing. But then, kind of like a child learns, you learn that, oh, when I think of the color green and smell the color coffee and try to move my left finger, my left index finger, like I notice that the arm kind of does this wiggle motion. And so then over time, your brain kind of learns to think in a certain way to be able to control it. And what it is just these electrodes picking up the signals and detecting that your brain is emitting a certain pattern. And then they interpret that pattern as, move left or move right, move up, move down.
Ah,
But
that's
this one
amazing.
actually gets implanted in your brain, the one they're using.
Yeah, because we've seen one where we were looking into one a while ago
Right.
where
That goes on the outside.
yeah, but that one had mixed results. But it looks like this one is much more fidelity.
Yes, because the skull blocks a lot of that electromagnetic signal.
Yeah, that makes sense. Makes sense.
So
Cool. So yeah, the next article we have is why airplane bathrooms have ashtrays.
And I assume it's not just because the airplane was built before smoking was banned.
No. So that's the shocking thing. And even new airplanes that are built now have ashtrays with no smoking symbols on them.
Wait, they have the
And
ashtrays themselves have no smoking symbols
yeah,
on them?
you should see some of the pictures of this
Okay,
article.
all right,
There's
I'm gonna
literally
click.
an ashtray with a big no smoking on it. And so you think to yourself, well, this is like some kind of like corporate, bureaucracy kind of thing. Like somebody didn't do their paperwork or something, and now all the airplanes have to have, But no, it's actually a result of something that was quite tragic. Somebody was smoking on an airplane while it was in flight, and there's nowhere for them to put their cigarette because smoking had been banned. So they flushed the cigarette down the toilet, and this seems like very bizarre to me. This what I'm about to say, but somehow that caused the plane to crash. Like almost
Oh.
everybody died. Like I don't understand how flushing a cigarette down a toilet can do that. Maybe they didn't flush it down the toilet because it said it was like poorly disposed of. Maybe they just put it in a trash can that
Oh,
caught
maybe
on
they put it in
fire.
where you put your paper towels.
Oh, yeah, that makes much more sense. But yeah, basically somebody did that and the plane crashed and everybody died. And so they decided that they're going to put ashtrays on planes, mandatory. And the idea is, you know, where they're getting at here is yes, in a perfect world you would have the no smoking symbol, above their head. You have the no smoking on the entry of the door, the no smoking all over the bathroom, the signs everywhere, and people just wouldn't smoke, right? But the reality is that eventually you have to come to terms with that. This is an addiction, and that people, their tendency, like if you did a use case study or something, you'd find that people just have to smoke, right? And there's like 1 in 1,000 or however many that just have to do it.
Uh,
And so by putting in the ashtrays, they're saying, well, look, you know, if somebody has to smoke, if they're going to just like, if they're willing to take that risk of the fine and the alarm detector going off and them going to jail and everything, and they're still going to do it, then like we have to have a way for them to do it without blowing up the plane. And then it goes from there into like a little bit of hyperbole, but it's actually really interesting on sort of like how do you design for human nature, and it gives like a doorknob as an example. So I thought it was pretty cool. So definitely give that article a look-see.
yeah. Well, so it did say that the airline crashed because the smoke. So, however it was improperly disposed of, it filled the cabin with smoke, and a bunch of people died from smoke inhalation because there's no, like when it's
Uh,
pressurized and everything, there's nowhere for the smoke to go,
oh
and
wow.
so it just keeps building in the cabin.
Oh, so it's probably what you're saying then. He put it in where the paper towels are and it caused a huge
Yeah, but it was in
fire.
1973, so it was actually a while ago.
Yeah, yeah, definitely.
So, all right, is it that time?
It's time.
Tool of the bye week.
Yeah.
All right, you're up first, man.
All right. So my tool of the bye week, it's actually two tools
Wait, wait,
depending
wait,
on
wait, wait, wait.
I
That's
know.
not fair.
I'm breaking the rule, man.
Oh,
But
now
you
you're
know,
gonna be
we've
twice as awesome as me this week.
we've been on vacation and want to come back, all pistons firing. So you're gonna only use one of these tools though, depending on what language you're programming in. The tools are BerkeleyDB and JDBM3. And basically what these are, let's say, let's say you want to store a lot of data. So what you want is a database, right? But when most people think of a database, they think of like MySQL, let's say. So, here you are. Let's say I'm writing some program to, I don't know, just like count the number of times someone visits my site and just store it on disk, right? So if I do MySQL, I have to set up a MySQL server. I have to, you know, like have that service running on a machine somewhere. I have to open that port because MySQL communicates through TCP. I have to write some MySQL client which uses the TCP socket. I have to serialize all my data and take my data, which might be a bunch of classes and functions, things like that, and turn it into like MySQL tables. I have to create the schema. Like there's so much overhead, right?
You can avoid some of that by using SQLite, but maybe that's for another week.
Oh yeah, yeah. Well, even with SQLite, you have
Yeah,
to do
but
a
you
lot
still
of
have some
that.
of those problems, yeah.
Yeah, you have to create the tables and
Sorry,
all
not to
that.
rain on your parade. Continue.
Yeah. So, the simplest thing, simplest database that, well, that I can think of at least is a key value pair, right? So basically, you just have a list of keys and like a hash table, basically, but on disk. And so that's exactly what Berkeley DB is. It's just a simple hash table that persists to disk, and you can put in keys. You can put in key value pairs, and then later on you can search for the key and you can get the value. And it does some clever caching. Um, but if you fall through the cache, it has a backup on disk, and it's also transactional. What that means is you can queue up a bunch of commands, and then you can commit the commands. And so let's say, for example, let's say I load Patrick's profile. I'm a web server, and Patrick logs into my server on his computer, and he goes and like changes his password. But then at exactly the same time, uh, evil Patrick, who's masquerading as regular Patrick, is on Patrick's phone and changes his password right there on the phone too, or changes something else, changes his like profile picture to a Hello Kitty picture, like at exactly the same time. That can cause issues. Like you could end up like saving two things twice, and one can collide and things like that. So you need to support transactions to deal with things like that. So the thing that comes in second, the transactional fail, it'll say, hey, something weird has happened. This data has been modified. You need to take a look at this and sort this out. So it handles like the very basics of what you need to have a what's called an ACID compliant database. And ACID, I don't remember. Do you know what it stands for, Patrick? It's like atomic,
Consistency,
something like
isolation,
that.
durability.
There you go. Perfect. So yeah, so you want that. So Berkeley DB has a bunch of bindings like C, C++. I think there's a Python binding. Or actually, I think it's part of Python. Actually, now, so if you're using Java, now Java already has a really nice collections framework, right? Like Java has map and hash map, tree map, linked list, array list, all these cool things. And since Java already has all this infrastructure, there's something called JDBM, which basically what it does is it gives you a map, like a Java map, but that map is backed by back to disk. So in other words, like you could write your program and have everything in memory, like all your usernames and passwords and all that in memory.
Mm-hmm.
And then once your program gets more mature and you say, okay, I want to deploy this, you can just replace the new hash map with JDBM3 hash map. And it'll just deal with everything under the hood. So it'll put things to disk when you need to go to disk. It'll load things from disk, etc., etc. And actually, BerkeleyDB is the most popular database because it's installed like multiple times on everyone's machine. Like even if you run Windows, Windows actually uses BerkeleyDB for a number of things.
Oh wow. So this
So,
doesn't
yeah.
handle over the network though, right? Like this is just for like local persistence to disk.
Right, that's right. And the other thing is it doesn't handle multi-processor. Although now there are some versions that are starting to get into that.
Okay.
But for the most part, it's, if you have a single program, it could be multi-threaded. And I think we talked about this, but just to recap really quick, multi-threaded means you have, a bunch of different threads that could all be doing different things, but they're all sharing the same memory. Versus multi-process, each one is a completely different program. And so BerkeleyDB and JDBM don't support multi-process yet, but they support multi-threaded. So
Nice.
yeah, so I mean, unless you're, a lot of websites use MySQL, but really, unless you're like some kind of powerhouse, you'd be totally fine. Like if you're doing your own coding, you'd be totally fine using something like this, and you'd save yourself a ton of time.
And then I think if you use like a key value pattern like that, right? So if you can reduce it to something simple like that, then I think it would be easy to move it over to network. Like I think Redis and other databases are kind of the same idea, but for network connected things. So if you
Yep,
wanted to add in sharing with other people, if you're using this key value mentality, there are other solutions that will take you to the next step.
that's right. There's CouchDB, Redis, there's HBase. Yeah, there's a ton of them, and we should maybe dedicate some time to that, in the future, because those are actually really, really interesting.
Right. All right.
Yeah.
Well, my
So what
tool,
about your tool of the bye week?
nothing nearly so enterprisey or program. I don't know. Anyways, Audacity. So I thought, oh, for sure we've talked about Audacity before, and maybe we have, and maybe my show notes are lacking. But I looked through all the show notes and I couldn't find it.
Wow.
And I decided we needed to talk about it because it is what you are listening through us, the power by which you are listening to us now. It's
Definitely.
Audacity. So that's what we use to record this podcast and edit it. And it before to do this kind of thing, you used to have to buy expensive software, and then when Audacity came around, it really changed all of that. So you can record, you can clean up, you can edit, you can mix multiple tracks together. If we had cool sound effects, we would be able to put them in. For right now, like we use it to do our intros and our outros.
Yep.
All that kind of stuff we do using Audacity, and it's amazing, and it's free, and it's open
Yeah.
source.
Yeah, I remember when I used to use Adobe Premiere, and then I think even before that I used something called Cool Edit, or maybe that was after. But yeah, I mean, at some point I used these programs. They cost like hundreds of dollars, and it was just like they were very slow and clunky. And Audacity works on Windows, Linux, Mac. It works on anything. Really nice interface. Lets you do all the like. They added all the polish. Like for example, I'm on my headphones, and there's an option so that it won't use your speakers, like won't use your microphone that's hooked up to your computer if you have the headphones plugged in and things like that.
Yep.
So
Very
that's good
nice
stuff.
and very powerful. And if you don't know about it and you want to do any sort of audio editing, that's where you should go.
Yeah, totally, totally.
So
All right, let's talk about Lua.
Lua. Now, how similar is Lua to a luau?
Very similar. It's
Because
both.
I like luau's.
I love luau's. The only thing, sometimes like you see that pig. What is that called when they have the pig with the
Oh,
apple in its mouth?
Yeah, it's suckling pig.
That's right. Yeah, the suckling pig. I think Lua core dumps a lot more than the suckling pig, but that might be because the pig is dead.
Oh. Okay, we might have lost people from our trying to be punny. Um,
But yeah, so Lua originated in Brazil. It actually has an interesting history. At some point, Brazil actually had like some kind of law where you weren't allowed to import source code. It's like the craziest thing I've ever heard of.
yeah, it's
But
like almost like a trade embargo of sorts. It's
yeah,
like we want our country to stay behind in technology.
maybe that's why so many of them use Orchid. Oh man. But yeah, so for people who don't know, Orchid is a social network, sort of like predecessor to Facebook or any of these. It was like even earlier than Friendster, and for some reason it's like massive adoption in Brazil, but that's it.
Yeah.
Um,
Although they said it's not anymore. Facebook surpassed Orkut popularity in Brazil.
Oh, really? Well, it's
Yeah.
about time. But anyway, so yeah, it started off in Brazil as a need to sort of create an embeddable language. But actually, although it sort of sounds like something, it was created because there was no alternatives in Brazil. The reality is it's a fantastic embeddable language. And at the time it was created, the only language even remotely, similar in its ability to sort of integrate with other languages is TCL or Tickle, as some
Yeah,
people
I mean, we're
call
talking
it.
like 1993.
Yeah, yeah, this has been around for a long time. And I don't know, I've used Tickle a couple of times, like very, very light usage, and I couldn't stand it.
Is that how you say it? I don't think I've ever heard it said that way before. I always just called it TCL.
Yeah, I've heard both.
Okay.
So let's see if here, I'll dig it up while
No,
you
it's
talk a little
okay.
bit.
It doesn't matter. But yeah,
Uh,
I mean, Lua is goes way back and it's been around for a while. And the interesting thing about it is that a lot of those things that used to exist around, aren't really around anymore. But there are certain artifacts we have today that are just from, older than you would imagine. Like even just like the Bash shell and Bash scripting and scripting on Linux or Unix type terminals. Like I mean, these things are things that have been around for a while and they haven't changed much. Um, and even things like Java, like when did Java first release? Uh-oh. We did
oh,
not do research.
I was in high school, so it must have been like 98 or 97.
Yeah, so I mean, you're talking about even older than that. It's saying 1995 was when it was first released. So
Yeah, yeah,
Lua
that's
was 2 years predating even Java, which is kind of crazy.
yeah, yeah.
And
Lou's been around forever. It's
and it's still
surprising.
relevant today.
Yeah, totally. So it is Tickle,
Okay,
according to Wikipedia, and
I will correct my
Wikipedia is
language
never
from
wrong.
henceforth.
But yeah, so Lua is interpreted. So it's like Python where it's compiled, but it could be compiled at runtime. So it has
So
that
it's like kind of
interpreted feel.
transparently compiled.
Yeah, exactly. So you can create Lua, I think it's called Lua C files, just like the PYC files in Python, and
Okay.
then you don't have to you do the compiling. Save yourself a little bit of processor, but yeah, for the most part, everyone just uses the source files and treats it as an interpreter. It's similar to Python as dynamic typing, but one thing that's very different in Lua, everything is based on tables and meta tables. And as opposed to, so if you think about like Python, for example, uh, Python has lists, has dictionaries, has classes. So a class in Python is has that sort of dictionary meta information, and then has the class assignment stuff. I think does Python have anything else? Core
Um,
structures. I think that's all of it. I mean, there's like sets, but sets are based on lists. Yeah, and then
I,
it has the usuals like string and number and all that. In Lua, all you have are tables and meta tables, which is something we'll talk about in a bit. But with just tables and the primitive data types, you can actually create a wide array of things in Lua. Um, should we try to do an example of meta table? I think I can try. I'll try and pull
okay.
this off.
Okay.
So,
So there are
so
features in all of these languages which people tend to get excited about or like talk in depth about on the internet. But that doesn't mean they, and I don't know if this is the case with Lua or not. I personally haven't used the meta table as part of Lua. But I mean, just before you go into the explanation, Jason, not to interrupt you.
oh, totally.
Yeah, so I mean, like there's even like we talked about in C++ about meta programming. This is something that like, gets talked about a lot because it's kind of cool and nifty and whiz bang. But that doesn't mean that the majority of code even uses it or ever thinks about it or ever even comes close to thinking about it. But it might still be talked about on the internet. And there's something that as programmers, we need to do a little bit of due diligence to avoid. And again, I don't know that this applies in this specific case, but just because something is discussed a lot on the internet or talked about doesn't mean it's something that you need to have in your program.
Yeah, totally. I mean, I wrote Lua for a little over a year as a scripting language to another program that our company is working on. But yeah, we didn't use meta tables or anything fancy like that. And to Patrick's point, most of the time in Lua, you're just taking advantage of how Lua can work with other programs. And so you're usually doing the fancy thing in that other program. But yeah,
So sorry, meta
yeah,
tables.
I'll give meta tables a shot. So first, let's talk about tables briefly. A table in Lua is a hash table. It's an associative array. So, for example, if you want in Lua, you can say, you can create a new table like my table equals, open brace, close brace. And then you could say like my table key Sunday equals 0. And my table Monday is 1, Tuesday is 2, Wednesday is 3, etc., etc. And so then later on, you could say, well, what is Wednesday? And it'll tell you 3 for the third day of the week, right? Um, or I guess the fourth day of the week, 0 based. But 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 basically, it's an associative array, so it just uses the equals operation for whatever type it's using. So you could have a table with tables in it, or you could have a table that maps numbers to strings. It doesn't matter, right? Because it'll just it knows how to compare if two things are equal, and so it can just hash anything.
So wait, so I mean, this is the second time we've kind of brought this up, but maybe a quick explanation of hash tables. Just like the idea of hashing is just taking one thing, running some sort of function on it, and producing a number. So like if you take one number, you might multiply it by 10, and that's your hashing function. That's not a very good hashing function. And then typically, like the simplest way to think about a hash table is just an array. So let's say you have an array that's size 10, and you want to store things in it that aren't necessarily obvious, that it should be an array. So like to Jason's point, if you want to store the day of the week, Sunday, somewhere in there, where should Sunday go? Well, you could take the letters of Sunday and like add the ASCII value of each of the letters, modulus, so divide that and take the remainder of 10 and say like that's the index in the array I'm going to use to store anything that's Sunday. Or like Jason's saying, you can use it kind of like more like maybe an enumeration where Sunday is kind of like the 0th object or stores 0 in it. So when you look it up later in the table, you can pull out the number 0 and you know that that is the value Sunday should have.
Yeah, totally. And so there's something in hash tables called collisions. So let's say, for example, let's say you did what Patrick was saying where you add up all the ASCII values and divide in modulus 10, and just coincidentally, let's just say Sunday and Wednesday, when you did that, they both had 8. That doesn't mean that Wednesday is going to replace Sunday. What happens with the hash table is when it goes to insert Wednesday, it'll see, oh, Sunday is already in this table, but Sunday and Wednesday are two different things. So then it'll do like what's called a deep compare. So first it'll compare just the hash function. And if there's a collision, it'll do a deep compare and say, is this the same item? Should I replace it? If it's not, then there's many different things it can do then. But yeah, basically, hash table is a way to get really fast lookup and entry of items.
And the reason why is because you don't have to search through the whole array or whole storage, because you know exactly where to go because of this hashing function.
Right,
That's
and you don't have to sort
part.
either, or like try and put things in order.
But it doesn't help you. If you do need a sorted list, a hash table won't help you.
That's right. So tables. So in Lua, let's say you have this this table with days of the week, Sunday, Monday, Tuesday, etc. But you want the table to do something special if it gets a string it never saw before. Like, this is sort of a weird example coming up with on the fly here, but let's say you had a table where let's say this is some kind of like cache. So it's a table to get the day of the week, but it's not always accurate. So for example, let's say the table just has English days of the week. So as the keys in the table, or it would be Sunday, so Sunday would map to 0, Monday would map to 1, Tuesday would map to 2, etc., etc. But then you could end up getting
Domingo.
Domingo, thank you. I couldn't remember any day for any language. Okay, so let's say you get Domingo. What you could do in Lua is you can create a meta table. And what the meta table will do is if there isn't a key in the table, but you try to look it up anyways, like you're trying to look up Domingo, but it's not in the table, it could fall back on the meta table. And the meta table might do something like go to some database that has like all the days of the week for all the foreign languages. So by using this meta table concept, if you want Sunday, you get it really quick. It's in the table, it's in memory. But if you want Domingo, which maybe you don't want that often, let's say because the majority of your business is in the US right now, but occasionally there's a Domingo that comes across, um, then you want to have this meta table that captures that, hits the database, and then returns, you know, whatever, what is that, 6 or something? Is Domingo Saturday or Sunday? I think it's
Sunday.
Oh, Sunday, because it would return 0 for that. So that's what meta tables that you do. And if you look on Wikipedia, there's some pretty clever examples. There's one where they do the Fibonacci sequence, which for people who don't know, it's what is it, n
The
plus
sum
n
of the digits of the two prior entries in the series.
right. So for example, like the Fibonacci number of 1 is 1, and 2 is
One,
2 is 1, but then 3 is going to be
two.
f of 1 plus f of 2, which is 2. And the Fibonacci sequence of 4 is going to be f of 2 plus f of 3, which is 3. Right. So they were able to use the meta tables to say, okay, I create a table, and 1 is 1 and 2 is 1. And then I create a meta table where if they want anything besides 1 or 2, it's the table entry of n minus 2 plus the table of entry of n minus 1. And so that'll kind of recurse backwards, and Lua is smart about caching. So let's say something happens where all of a sudden you have an influx of Spanish-speaking people hitting your website, and everyone wants Domingo all of a sudden. Lua will actually cache that value, so you won't have to just keep hitting the database. So it's clever about that. This is also called memoization. When you do memoization is more with respect to recursion, but if you do these kind of things where like you cache data in a table, in a hash table, so you don't have to keep calling a function, Lua will do that for you, which is pretty clever.
So it's cool because in some ways you're able to just use a table that in theory has infinitely many entries in it, has all of the Fibonacci sequence in it. But then only when you actually try to use some entry of the Fibonacci sequence does it actually go and figure out what that number should be.
Right. This is also called lazy, like either lazy loading or in this case lazy calculations. It only calculates what it needs to.
That's right. Interesting. So what are so we kind of hinted at some of the strengths of Lua that we already mentioned, that it was used as like a scripting language. And while it's kind of used as a scripting language, I guess, because it works so well with C and C++. It's really easy to embed it. And you said you've worked with it this way before?
Yeah, definitely. So Lua was designed to integrate with C specifically, but later on with C++. And so, just to put this like in just a contrast, let's say you want to embed like Python, for example. Well, you have to use this like really clunky like Python C API, and like everything is kind of based on these functions, and you have to like convert like Python. Oh, I forgot the.
Well, so there's calling C from Python, and then there's scripting events in C with Python.
Right, yeah. And so both of those get complicated because you have to transmute the types. So in Python, you have lists, you have dictionaries, you have all these different types, right? As we talked about at the beginning. And each of those, you have to create some kind of analog on the C or C++ side, or you have to create some kind of like accessors. So you have to be able to say like, oh, this is a list in Python, so I want to get the 4th element in this list in my C++ program. Or I have this C++ array, I want Python to think of this as a list, and this kind of stuff ends up becoming like, no matter how you do it, ends up becoming really clunky. Lua, it's kind of a double-edged sword. Like it only has tables, but on the plus side, it only has tables, right? which map exactly to C++, hash maps. So it makes it very easy to integrate the two languages, and even easier because since so many people are doing this with Lua or embedding it, they've created some amazingly streamlined libraries to make this happen. So one is LuaBind, which I used briefly, but the second one I'm more familiar with is called Diluculum, which I think it's some African word or something, but we have a link to the in the show notes so you guys can look it up. But basically, it's for C++, and it has a thing that maps like Lua tables, actually anything in Lua, to the analog in C++, and it sort of does it all transparently. So you can just say, hey, go to the Lua world and get me this variable. And even like on the other side in your Lua program, you can say, hey, go to the C++ world and get me this variable. And it does it all like very transparently.
Nice.
Yeah, it's pretty awesome.
So because of that strength, you can think like anywhere you'd want to script something. So things you might want to script, like often you hear this in like video games. So video games want to have some scripting done where you control what happens when a player swings a sword and hits somebody. What happens. You can script that event. Like I want to decrease damage by 10, and I want to, trigger effect magic lightning bolts, onto the screen. And these kinds of things you can imagine, like through playtesting and stuff, you might want to tweak those, but you don't want to have to go in and actually edit the code or have to even know what the code means. You might want to have other people be able to make those changes. And so scripting languages just provide that flexibility to you. Yeah,
exactly. I mean, most of these game studios, the people who are creating the content, they're not programmers. They're often like game designers who are just sort of like playing with the different variables. Like, oh, if I make magic more powerful, how does that affect the game? And let me play for a few hours on this setting. And they can't afford, even if they did know how to program, they can't afford to be recompiling code all the time and things like that. They want to just make changes quick. And so Lua sort of gives them that flexibility.
Yep.
Lua is also very fast. Because it only has tables, basically hash tables. It doesn't have to do a lot of thinking. It doesn't have a lot of complicated instructions or anything like that. And so the execution speed is awesome. And you can even use Lua in like embedded devices and things like that, which don't have don't have strong processors and not worry about it.
Yeah. So there's some good strengths and weaknesses. I think you're kind of alluded to the fact that they really only have tables and meta tables. So, yep. I mean, that's a strength that it's very simple that way, but also like everything, that can be a weakness as well, that it doesn't always obvious how to get what you need to get done.
Yeah, totally. I mean, people have tried to shoehorn so much into the tables and meta tables. Like someone created like a class-based infrastructure where, if you have getters and setters as like items, keys in the table, but it's really hacky. And then once you start doing things like that, performance sort of goes down the tubes because the language isn't really designed for that. Yeah. It's not really designed for you to hit a meta table every time you want to access a variable. And the other weakness is that it's just not very fully featured. No one's taken the time to bind your favorite library to Lua, chances are. If you really like fluid dynamics, or you want to use like some kind of physics engine, or if you want to do something like some kind of heavy like differential equations or something, chances are that hasn't been, there's no binding for Lua for that. And that's mainly because, Lua is designed to sort of be a supplement to another language. So you're just not going to get the kind of features you get. Like in Python, for example, if you want to just, let's say you're streaming out a bunch of data to disk, and you want that data to be compressed. Well, there's a gzip, library, which is part of the Python standard library. So there's compression built in. You can say, look, write this to disk and make it compressed so that it doesn't take up as much space. You're not going to find that kind of functionality in Lua. So if you need those kind of bindings, you're going to have to write them yourself, which could be really tedious. So
yeah. But there are some libraries. It's not to say that it's not fully featured or functional. And we have a link here. But I mean, there are libraries for it, and it's fairly well supported. It's not, and again, being around so long, it kind of has to be. And it's just one of those things you're gonna have to go in and say, this is what I get, and not expect that when you find a cool tool that it will have a binding for Lua.
Yeah, totally. Yeah, I mean, to Patrick's point, we'll post a link on the show notes, and there are a ton of different libraries for Lua and things like that. So definitely, I wouldn't shy away from it because of that. But yeah, I mean, definitely, if you have some existing application and you find yourself just constantly recompiling it and changing constants and recompiling it, then you probably should just be using Lua.
So the people that use it, I mean, we talked about it tends to be scripting. So World of Warcraft uses Lua as their scripting engine.
Yep.
So, other people, I know there's some mods and stuff that are written with scripting language in Lua. Also, I use this program to do some photo editing. Lightroom, which is an Adobe product that does workflow for taking pictures and editing them, and then kind of making libraries or catalogs and saving them out. And all the
Nice.
UI in there was scripted in Lua.
Yeah, I mean, UI is an obvious choice. So, in general, just to talk a little bit about things like why you need scripting, right? Now, we talked about a couple of the reasons, with the recompiling and things like that. But also, some things like UI specifically is just a pain to write in a statically typed language like C++. So, for example, let's say, you want to hit a button or a menu item, and when you hit that button, you want a function to be called. Well, in C++, to do that, you have to create some kind of interface class. It's a virtual class, which has some method called, like perform function. And then all of your classes which need to have this function need to inherit from that class. And then you need to like downcast the class when you pass it into the button. And you have to go through all these hoops, right? But if you have an interpreted language like Lua, which is driving your GUI, then you can just bind different actions to different buttons. And Lua doesn't care about the types of the actions. So it doesn't care if like, oh, this one function was part of a class, and now like you have to do all sorts of crazy wizardry to get access to that. Lua, because it's a scripting language, it doesn't have any of that overhead, and so it makes it great for doing UI.
Yeah. Yep. So Lua.
Yeah, give it a shot, man. Don't write your UI in C++ if you can help it.
So on general notes, I guess meta notes, kind of like meta tables. We have gotten some good feedback from people, some extra language suggestions, some people writing in to tell us that they've found tips or tricks that we've mentioned useful. And as always, we appreciate that. We are always glad to be out there and helping people and at least entertaining you, hopefully.
Yeah, totally.
So if you do have something to say, you could check us out on Google+. We have a Programming Throwdown Plus page, and we're pretty good about putting the new episodes linked there. Or, if you have comments, you can, of course, put them there. Hopefully positive, but we're willing to take criticism as well.
Yeah,
and,
totally.
You can always, if you have something you don't necessarily want there, you can always email us at programmingthrowdown@gmail.com.
Yeah, one interesting thing, somebody wrote in and said that I guess they can't access the G Plus page unless they have a G Plus account. Is that true?
Oh, I don't know.
Yeah, I don't know. To be honest,
Maybe.
I haven't tried. Yeah,
We shall try.
I thought it was public. Like I thought there was a public section. But if as Patrick was saying, just to reiterate, if you can't access us on G Plus for whatever reason, don't hesitate to shoot an email to programmingthrowdown@gmail.com.
Yeah, and I guess if you can't see the Plus page, you can also check out the blog.
That's right. Totally.
Programmingthrowdown.blogspot.com.
Yeah, you could follow the blog. We definitely cross-post everything on there. And
then there's also
public.
you can put comments there, and I believe that we don't check that very often, but I think it does actually send us an email when somebody posts a comment there.
That's true. Yep.
So we try to be easy to reach. We're here for you people.
Definitely. If you have any, we've had a couple of requests and we want to fulfill the requests. So definitely Java is going to be coming down the pipe and Go is going to be coming down the pipe.
You're foreshadowing. Now we have a lot to live up to.
But if there are any other requests from the audience, don't hesitate. We definitely read every one of them. And, we have a backlog that we're getting to.
Yeah,
so.
And don't be offended if we don't reply to you or, whatever. We are listening. We are taking it in. And yep, hopefully we'll get there one day.
Yeah. I mean, if you say you want a language, you're going to get it. It just might, it's just in the pipeline.
I'm actually surprised. I did make up a list and the list is pretty long. So there are a lot of languages to go through.
Yeah, totally.
So, and then probably it's one of those things where is there more created than we're talking about? Like, is there at least one created every 2 weeks?
Oh man, there could be.
Uh-oh. We might never finish this job, Jason.
Oh, it could go on forever.
Uh-oh.
Now I know how movie critics feel.
All right, on that note, That's all I got. Everyone, have a good time.
All right, see you guys later. The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share Alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.